Okay, we're in section 30 of the notes, and we're going to do the homework now. Again, the point of this is not me doing your homework. The point is just getting you guys to do your homework. The amount of time you spend on this may vary, but typically once you understand the material, the homework should go very quickly. The problem is studying to understand it. That's what takes time for students to study what was presented in classroom, possibly reading book, going to the web, whatever. You need to study the material. Once it's understood, though, these antiderivatives that we're asking you to do should be relatively simple for you. All right. So I'm going to switch boards, and I'm going to go to my whiteboard now, and we're going to do the problems. And again, this is homework. This is something for you to do. All right, you're seeing my whiteboard now. So, one problem at a time. And, certainly start off simple. It says find the general antiderivative, this over here. And the general antiderivative, at least in most textbooks, they write down it's f of x, with the understanding that if you were to differentiate this with respect to x in this particular problem, you'd get the small f of x. So then, how do you do that? We have rules for it. But again, you don't need rules for it. You can think through it if you want. But what do you do over here? Well, let's write this down. So the big F, we'll check whatever we write down, by the way. Well, let's see. It's going to be, what would differentiate the x squared? Be x cubed, right? And certainly that differentiates to 3x squared. I want 15 though. So I'm going to say 5. All right. So let's see if that's true. 3 times 5 is 15. Looks pretty good. And then reduce the exponent by 1. Good. You should always know that, though, there's a constant over here that we don't know what it is. And the reason that all constants differentiate to 0. So I'm going to put a box on that. But before I commit to the answer, I want to check it. Does the derivative of this thing over here with respect to x equal what we say it should equal? Let's take a look at it. Let's give you 15x squared. Derivative of c is 0. And it does work out. And that's, of course, the answer they're giving us over here. All right. That's a general antiderivative. Let's go to the next page. And, same story over here. And I'm probably a little more difficult, but the bottom line is we basically have rules for this stuff over here. And again, we're looking for the general antiderivative. And the way we're going to do this, we're basically going to use a rule-based system. So I'm going to say 11x. I'm going to increase the exponent by 1. Whatever I do, though, I'm going to check it, though. So if you increase that by 1, you would get 2/5. And then we divide by the exponent, which is 2/5, plus some constant integration c. Again, I'm going to simplify this, but I'm not saying it's the right answer. I'm just saying I'm going to simplify it. And what would that give you? 11 divided by 2/5 is 55 halves x to the 2/5 plus c. So I'm going to say this is my answer. But before I walk away, I want to check it. I want to check to see if f prime, that big F, is equal to little f. I don't know. Let's see what happens. And what do you get over there? Well, f prime, what's that going to be equal to? 55 halves. I'm checking. Times 2/5 times x. We're going to reduce that by 1. That's going to be minus 3/5. And the derivative of c is 0. And what's f of x? It's 11 x to the minus 3/5. Is this true? Well, 2's cancel. 5 goes to 50 11 times. Yeah, it's good. So what do? Look at your key to make sure you're matching it. All right, we are. Let's take a look at this one over here. And again, I'm looking at it. I think it really doesn't look that bad to do, but I make mistakes. And we're going to check it just by, I guess differentiating, right? So I'm looking for the big F. It's going to be 13. Well, what differentiates a cosine would be sine, right? And what differentiates a sine would be minus cosine. It's going to be plus 8 cosine of x plus c. All right, I'm going to say that's my answer. And I'm going to check it. What is f prime? Well, that's going to be 13 cosine x minus 8 sine x plus 0. And is that what we say it should be? Yep, it looks good. So I know this is my correct answer. So let's put this over here, and I'm seeing it, 13 sine x, 8 cosine x plus c. Things are working out pretty nicely. Let's just put over here. Now it's got e to the x in it. And my big question is, what differentiates the e to the x? Well, I know that. That's e to the x, right? And then I got this guy over here. So minus 10 x, I'm going to increase the exponent by 1. That'll be minus 1. And I would divide through by minus 1 plus some constant. And that's going to be, let's see if we can write that down. 18 e to the x plus 10 x to the minus 1 plus c. So I'm going to say that's my answer, but I don't know. Maybe I should check it first. So what's f prime? That's 18 e to the x minus 10 x to the minus 2. And the derivative of c is 0. Is that what they say it is? Let's take a look. Looks good. So that's our answer, and our answers are listed for you as well. All right. So far the problem's really, going along pretty smoothly. I don't see any problems with these things over here. And this is a problem where they're giving me dy dx, and they want me to go back to the actual function. So really what I'm saying is that dy dx is y prime, and that equals 6x cubed. So I'm gonna go backwards, and I'm gonna say y. I'm anti-differentiating, and what would that be? I do what? Increase the exponent by 1, right? So x4, and I divide by 4. We'll check it, whatever we say, plus c. I'm write this down. So y equals, that would be 3 over 2 x4 plus c. Let me write down y prime. I'm not saying this is my answer, by the way. What's it going to give me? 12 halves x cubed plus 0. And that's 6x cubed. Well, that works beautifully. So I know that this is the form of it. And then what do they want to know? They tell me y evaluated when x is 0. This is the same thing as saying y at 0 is equal to 9. And if that's true, well, let's plug it in. Well, I'm plugging it in here, and this would give me what? Y equals, well, if x is 0, 6/4 is 0, 0 plus c, and that's supposed to be equal to 9. So what's c? C has to be 9. So I got my answer. And what's y going to be equal to? Let's simplify it. 3 halves x4 plus 9. Let's look at the key, and we're looking at the same answer. Let's go to the next one. Next one a little bit different. I got a t in it now, and I'll write this one down for you. So y is a function of t. I'll write this down over here. Y is a function of t. I just don't know what it is, by the way, but I know it's a function of t. What I do know is I know y prime. And what's y prime? It's dy dt. It's going to be 3t to the 1/2 power. We're going to go backwards to y now. How do I do that? Increase the exponent by 1. Divide by the new exponent, which is 3 halves plus c. I got to clean that up, don't I? So what do you get over here? Yt. Well, that's going to be, divided by 3 is like multiplying by 2/3. So it's going to be 2t to the 3 halves plus c. By the way, they gave me a condition. They say y1 is 7. So I'll write this over here. Y1 is 7. What would that evaluate to? Y1. It would give me 2 plus c. So I think I know what c is. C would have to be equal to 5. So what's y of t? We'll check the key later. It's going to be 2t to the 3 halves plus 5. Now, on exams, you don't have an answer key, so you should check it. And what they say y1 is 7. Well, let's see if that would give me 2 plus 5. That's true. And they told me the derivative was, let's do that derivative. So you check that out, by the way. What did they say the derivative was? Oh, 3 root t. What would that give you? 2 times 3 halves. T, take away 1, that's a half. And what's that going to give you? 3 root t. That works out beautifully as well. This is the answer. Let's check in the answer key, though, and I'm seeing the answer as well. Let's go to the next one. Number 7. And this is z is a function of t now. I'm going to put this down for you. So z is a function of t. And what do I know? I don't know what it is, but I do know that z prime, which is dz dt, is t to the minus 3 halves. Let's go backwards. So zt. I'm going to increase the exponent by 1. Well, if you increase minus 3 halves by 1, that would be minus 1/2. And then I would divide by minus 1/2. We'll clean that up later, plus some constant, because all constants differentiate to 0. Let's write this down a little simpler. And what do you get over there? Well, this would be minus 2 t to the minus 1/2 plus c. Now let's go see if they asked that question. I don't think they did. Oh, what did they say? They say z Whoops, sorry about that. They said z of 25 is equal to minus 15. Let's write that down. What do you get? Minus 2 over the square root of 25, which is 5, plus c. All right, I need to solve for c. Let's see if we can do that. I can multiply both sides by 5. That's going to be minus 75 minus 2, multiply by 5, plus 5c. I'm going to, let's see, add 2 to both sides. It's going to be minus 73, 5c. A nasty number, I know that. And divide through by 5. And when you get c equals minus 73 fifths. So I think I know the answer over here. I'll write it down for you. So it's going to be, I know what c is, by the way. At least I believe I know what c is. So it's going to be minus 2 over the square root of t minus 73 fifths. All right, let me make a fraction more over there. I'm gonna put a circle in this. And by the way, if I were on the exam, I'd say, I wonder if I did that right. Well, what I would do is I'd check it. And to check it, what do you have to do? You know, plug some numbers in over here. And the first thing I like to do is z evaluated when t is 25 equal to minus 15. I don't know. Let's take a look at that. What would you give here? I'm just checking. Minus 2. Square root of 25 is 5. Minus 73 over 5. Whoops, 73. So 73 minus, minus 75 over, minus 15 works out beautifully. Let's look at the derivative of it though. And that doesn't look too bad to me. So I'll write down, I'm trying to differentiate this over here. And if I differentiate, I'm just checking my work, by the way, it would be 1. Because, you know, minus 2 times minus half is 1, and t to the minus 3 halves. And the derivative of minus 73 over 5 would be, of course, 0. So is that what they said it was? Yeah, that's good. So let's check our k, and I'm seeing it, and I'm glad I'm seeing it. All right, let's do the next one. This number 8, and I'll look at it. They give me dy dx, and I'm going to say y is the function of x. And I don't know what it is, but I do know that y prime is equal to 3 sine x. Now, what I'm going to do, I'm going to take its antiderivative, and y of x would equal 3. Well, what differentiated sign would be minus cosine? So I'll put this over here as minus 3 cosine of x plus c. All right. Let's put the next thing down, which they say y at pi over 2 is equal to 9. What's the sine of pi over 2 is 0. So c is 9. All right. So let's write this down. Y of x is equal to 9 minus 3 cosine of x. Now, granted, when you're doing homework, certainly if you're on exam, I would check it, but you're doing homework, you got a key. Let's look at the key, and I'm looking at it, and I see that answer. All right, I feel good about that. All right, let's go to the next one. Next one is number 9. And again, these are relatively simple questions if you understand them. If you don't understand them, they're not simple. And y is a function of x. I just don't know what it is, but I do know y prime, which is dy dx, is equal to e to the x. Now, going backwards, this is pretty simple to do. It's going to be e to the x plus c. What do they tell me? They tell me y at 4 is equal to 0. Well, let's see what we get over there. What do you get? You would get e to the 4 plus c. Well, I think I know what c is now. C has to be equal to minus e to the 4th power. So I'm ready to write down y to the x now. It's going to be e to the x minus e to the 4th power. Again, when you're doing homework, you have an answer key to look at. If on exams, I would check it by differentiating and evaluating. All right. So let's see if we got the right answer. And I got it. This is bingo. Let's go to number 10. Number 10 is, they say find the first derivative and the function itself. They're giving me the second derivative. So I got to work my way backwards. And this is 54x. Now, the assumption is a derivative with respect to x. So let's go backwards one stage at a time. So let's give you, well, that would be x squared. When you divide by 2, you get 27 plus c. I'm going to use this information to figure out what c is. And they tell me f prime at 0 is equal to 9, right? So it's going to be, well, it's 0. That's easy to do. So c has to be 9. So now I found f prime of x, which was one of their questions, which is 27x squared plus 9. I'll put a box on it. They did ask for that. And I'm looking at the k. And I clearly see that. Now let's go backwards one more step. And what again? I'm going to go back to f of x now. What's it going to be? Well, x cubed, I'm dividing by 3. So 3 goes into 27 9 times plus 9x. Oh, I got another c here. So I'm going to call it d, right? Another constant. Now, what do I know? I know f of 0 is equal to 5. So what does this tell me? It tells me d is 5. So I can write f of x down now. What's f of x? And we'll check with the key later. Mistakes happen a lot, by the way. And that's why we have a key for you to look at. When you go over here, let's take a look. And I'm seeing it. I'm seeing the 9x cubed plus 9x. Yeah, bingo. All right, let's take a number 11. I'm on a roll. And I think I'm ready to do this one over here. It might be more difficult, but this is a second derivative. And what do I have to do? I got a lot of work to do. All right, so let's put this over here. So I see that, I don't want to write that down again. It's too much writing. I'll write down f prime. And what's that going to be? I have to increase it by 1, right? So it's x4. And does 4 go into 140? Yeah, 35 times. Let me check that. That's 120, 20. Yeah, 140. Minus, that would be x cubed. Does 3 go into 84? 28 times. Let me just make sure that's true. What's 3 times 28? 60 and 24. 84. Yeah, looks pretty good. And then it's going to be plus 18x. I'm sorry, plus x squared. Does 2 go into 18 9 times? Let me check that. 2 times 9 is 18. Looks pretty good. Minus 12x. That was simple. Plus some constant. I don't know what it is. Now, of course, what am I going to do over here? I want to see if I can figure it out. And they tell me that f prime at 1 is equal to 8. Well, this is going to be a tough problem, isn't it? Let's take a look. It's arithmetic, though. So what do I get? 35 minus 28 plus 9, plugging in 1, by the way, minus 12 plus c. I got some work to do, don't I? So 8, let's see. I'm going to do 35 and 9. That would be what? That would be 44, right? And then minus 28 minus 12 is minus 40 plus c. I can still do some work. 8 is 4 plus c. So I'm going to say, I think I know what c is now. C is 4. All right. So let's write this down. F prime, they did ask for it, is equal to 35x4 minus 28x cubed plus 9x squared minus 12x. And I think C is 4. I can put a box on it. All right. Now, what's nice about having an answer key next to you, we can check it, see if we got it right. And I'm looking at this, and I'm looking at this. Did I get it right? 35x4. Gee, I got that right. Minus 28x cubed. I got that right. Plus 9x squared. Gee, I got that right. Minus 12x. Yeah, got everything right. Now, next thing I got to do is I got to find F. All right. How do I do that? Go backwards. Let's see. That's going to be x5. 5 into 35 is 7 times. Minus x4. 4 goes into 28 7 times. Whoa. Plus x cubed. 3 goes into 9 3 times. Wow. Minus 12x squared. So it's x cubed. And 3 goes into 12 4 times. Plus 4x plus some new constant d. All right, let's see if we can figure it out. And what did they tell me? F of 1 is 3. This is going to be a killer. F of 1 is 3. Thank God for one note. It's an easy number. Three, let's see, 7 minus 7 is 0. And 3 plus d. What's d? D has to be 0. So I think I found f of x. But again, when I say I think, I don't know if it's right. Maybe I made a mistake. They were pretty common with the numbers, though. Let's check if I got it right. And let's see, 7x5 minus 7x4, 3x cubed minus 6x squared. I made a mistake. It's not good. Made a mistake. All right, I made a mistake somewhere. So something's wrong. So let's go back and look. And it's going to happen to you. Now, by the way, mistakes are going to happen to you. You don't want them to happen on exams. You want that when you're doing homework, and that's the whole point of doing homework. So you go back and say, geez, I wonder what I did wrong. Well, I know I got the first derivative right? I checked that already. I wonder what went wrong over here. I must have went some wrong on the derivative over here, right? So let's take a look at it. And I really mean, I can take a look at this. So let's see if I did the first one right. 5, that's good. 5 goes into, yeah, that's 7. 4, 7 again. And then 9 would be 3. 3 into 9 is 3. And then, I see it now. So it's, I said x squared, right? I see the error right now. Let me just clear that out now. And by the way, I'm not saying it's the only error. I'm just saying I see an error. The error is right over here. Let me put that down. So that's going to be x squared. I guess I got dizzy. And 2 goes into 12 6 times. Okay. And then, yeah, it's okay now. And I say it looks okay. I'm not saying I've got it right. And F1 is 3. I'll put this over here. 7 minus 7 plus 3 minus 6 plus 4 plus D. Let's see if we can do this. 7 minus 7, 0. 3 minus 6 is minus 3. Minus 3 plus 4 is 1. 1 plus D. And D would equal 2 then, right? Let's write this down. We'll check our answer again. And yep, you're going to make plenty of mistakes. Make those mistakes before you get on the field, so to speak. All right. And that's the analogy to sports, that if the team doesn't practice, they're going to do really poorly. All right, let's take a look at K, see if we got it right. Who knows? Maybe we got this one wrong too. I'm seeing the 7x5. I'm seeing the minus 7x4, 3x cubed, minus 6x squared, plus 4x plus 2. Looking good. What are we going to do now? I guess we'll go to the next question, and that's going to be number 12. All right. Now, I'm looking at this one. It says, given that, f double prime of cosine x is equal f double prime of x equals cosine x. Well, I got to go backwards again. It doesn't look that bad. I'll write this over here. So I'm going to write down and go backwards one step at a time. Whoops, go back to black ink. I'll write down f prime. Well, that would be sine, right? Plus c. Let's plug this in. F prime of pi over 2 would equal 1 plus c. And they said that's equal to 4. So now I know f prime of x is equal to sine x. What's c? It'd have to be 3, right? I get that one right. All right, let's go backwards again. And let's see if we can do that. F of x. Well, that would be minus cosine x, right? Plus 3x plus d. And they say f prime, f of x, f of pi over 2 is 13. Well, it's going to be a little tougher, isn't it? So what's the cosine of pi over 2? It's 0, right? So it's going to be 3 pi over 2 plus d. So I think I can get d. D is going to be 13 minus 3 pi over 2 is equal to d. I like to clean it up. And again, don't feel obligated to do so, but I like to clean things up. So it's going to be 2, 26 minus 3 pi. And let me write this down for you. So f of x would equal d, which is 26 minus 3 pi over 2 plus 3x minus cosine x. Let's look at the k, see how we did. And let's see if I'm seeing it. I'm seeing the 3x. I'm seeing the minus cosine x. Now they wrote it down as 13 minus 3 pi over 2, which is the same thing. So I feel good about that. And we're done. It isn't that bad, by the way. Now, of course, I say it isn't bad if you're doing the study and the preliminary work, and you have the foundational building blocks to learn calculus. What does that mean? That you've studied and have a good understanding of algebra and the pre-calculus, which includes the trigonometry. All right. Thank you.